You ever been in the middle of a huge download or an important video call and everything just works? Yeah, of course you have. But have you ever stopped to think about the invisible safety nets that are working 24/7 to keep you online even when a piece of hardware dies? Well, today we're going to pull back that curtain and look at the amazing tech that keeps your network connection from ever going down.
I know, it sounds super dramatic, but it's totally true. Right now, as you're watching this, your entire connection to the whole World Wide Web, it all hangs by a single thread. It hinges on one critical device.
And here's what that looks like. You've got your computer, and it needs to talk to the internet. To do that, all of its traffic has to pass through one single device, your default gateway, which is usually your router. Think of it as the only exit door out of your house. Every single bit of data, every search, every meme has to squeeze through that one single point.
So that's the most important link in the entire chain. But what happens if that device just goes offline? If that single exit door suddenly slams shut and locks itself? Well, just like that, you're cut off. Your connection to the outside world is totally gone.
Okay, so let's really dive into this and understand what makes this gateway so fragile. Because this is the fundamental problem that network engineers have been trying to solve for years. Let's put an official name on it, the default gateway. It's just the path that your devices use to talk to anything outside your local network. It's the on-ramp to the internet superhighway. Without it, you're basically stuck just driving around your own block.
And here's the really wild part. You might be thinking, hey, no problem, I'll just buy a second router for a backup. Smart idea, but there's a huge catch. Your computer is only set up to talk to one default gateway. So if that man router dies, your devices have no clue that a backup even exists. They'll just keep sending traffic to a dead end, knocking on a door that's never going to open.
So how do we fix this? How do we make that backup router actually, useful? Well, this is where engineers came up with an incredibly clever solution. It's not about better hardware. It's about creating a brilliant illusion.
And this quote right here, it nails the core idea. Instead of trying to teach our computers about a bunch of different routers, we just trick them. We make them think there's only one router, an ultra-reliable, never-failing super router. It's basically a magic trick for your network.
And this illusion has a name. It's called a virtual router. Now, you can't go out and buy one of these. It's a team of 2 or even more physical routers that all agreed share one single identity. They share the same IP address and the same MAC address, which is like its hardware fingerprint, pretending to be one single device.
The way it works is just beautiful. Your computer gets the IP address for this virtual router. It sends all its traffic there, having no idea that behind the scenes, one physical router, the active one, is doing all the work. Meanwhile, the other router is just sitting there quietly in standby, ready to jump in at a moment's notice. And the best part? Your devices are completely oblivious. The whole process is totally invisible to them. Okay, so that's the setup. But what happens at that critical moment? What happens when the main active router actually fails? Let's check out how this clever setup pulls off an instant, silent takeover.
The secret is constant communication. The routers in this virtual team are always sending these tiny little hello messages back and forth. You can think of it like a heartbeat. It's their way of saying, hey, I'm still here, I'm online, everything's good.
And when that heartbeat stops, the failover process kicks in like clockwork. Step 1, the standby router notices the silence. It's not getting those hello messages anymore. It doesn't wait around. Step 2, it immediately promotes itself and takes on the role of the new active router. And finally, step 3, it takes over that shared virtual IP and MAC address, and just like that, traffic keeps flowing without missing a beat.
And this right here, this is the whole point. From your computer's perspective, absolutely nothing changed. The address it's talking to is still online. The video you were streaming 1 millisecond is still streaming the next. You don't get disconnected, nothing buffers. The takeover is completely seamless.
So this whole concept has a name. It's called First Hop Redundancy, and there are a few different ways to do it. So let's look at one of the most popular ones out there, Cisco's Hot Standby Router Protocol, or HSRP, to see how these routers figure out who gets to be the boss.
I mean, you can't have 2 devices trying to be in charge at the same time, right? That would be chaos. So there has to be some kind of election process to pick a leader and a backup. So how does that work?
Well, it's actually way simpler than you might think. Each router in the group gets a priority value, just a number between 0 and 255. When they boot up, they all shout out their number, and whichever router has the highest priority wins. It becomes the active router. It's that easy. Check out this perfect example.
Let's say router A has a priority of 200, and router B has the default, which is 100. Well, it's not even a fair fight. Router A is going to win that election every single time and become the active router, while router B settles in as the standby. This one little number gives the network admin complete control.
Okay, but think about this scenario. Let's say your main router, the one with the high priority, it fails. The backup takes over, everything's working fine. Then you fix the main router and plug it back in. By default, nothing happens. The backup just keeps on being the active router even though the stronger preferred router is back online. That's not really ideal, is it?
And that's exactly why we have this feature called preemption. Think of it as a take-back button. When you turn on preemption, it lets a router with a higher priority say, hey, excuse me, I'm back online and I'm supposed to be in charge here. It forces a brand new election, takes back the active role, and makes sure your network is always running in its best, most optimal state.
All right, let's zoom out for a second. I know we've been deep in the technical weeds here, but this whole concept of automatic failover, it is absolutely fundamental to the always-on internet that we all rely on for, well, pretty much everything these days.
Now, we've been talking a lot about Cisco's HSRP, but it's not the only game in town. There's VRRP, which is a big deal because it's an open standard, meaning hardware from different companies can all work together. And there are even more advanced protocols like GLBP, which can actually use multiple routers at the same time to balance the load and make things even faster.
And that brings us to the official name for this whole incredible system, this magical, invisible ability for a network to basically heal itself when its main gateway fails. It's called First Hop Redundancy. This is the reason a single hardware failure doesn't bring down an entire hospital's network or crash an e-commerce site on Black Friday.
So, the next time you're online and everything just works perfectly, you'll know about the silent elections and the instant takeovers that are always standing by, ready to happen. And it kind of makes you wonder, right? Now that you know how this works, what other invisible systems in your life, from the power grid to the airplane you're flying on, depend on this exact same kind of intelligent, instant redundancy?